Here we have the Cauchy-Euler equation, x squared y double prime plus 3xy prime plus y equals 0. So as usual, we're going to guess y is equal to x to the r to try and find the homogeneous solutions. And so we're going to need the derivatives as well. So it's going to be y prime is equal to r x to the r minus 1, and y double prime equals r times r minus 1 times x to the r minus 2. All right, next we get to plug that into the differential equation. So we get x squared times y double prime, so we get x squared times r minus 1 times x to the r minus 2. Then we have our plus 3x times, let me fix that 3 there, times y prime, which is r, times x to the r minus 1. Then we have our plus y, which is just x to the r. And we want to try and find r, so that all equals 0. Alright, so once again, simplifying, we're going to have x squared times x to the r minus 2, so that combines to x to the r. So we have our r times r minus 1 times x to the r, plus, then we have our x times x to the r minus 1, so again, that's x to the r. So we end up with 3r x to the r, and then plus x to the r equals 0. Factoring out the x to the r, we'll end up with, let's expand that as well. So we have r squared minus r. We have plus 3r from the middle, and then plus 1. That's all times x to the r equals 0. All right, so our only option to get this to work for all x's is this polynomial here has to be 0. So we have to pick our r values for that. And so, let's see, r squared, I have a minus r plus 3r, so that's plus 2r. And then plus 1 equals 0. And I think I can factor that one. So that ends up being, let's see, I think it's r plus 1. R plus 1 squared equals 0. Now that looks right. So this is a repeated root case. So we only have one root. So the root is r is equal to negative 1. We'll get this guess to work. Right, that's only one homogeneous solution, so we know that y1 equals x to the negative 1 power, which, right, another way to write that is 1 over x. So then y2 is equal to, so what you do in this situation is you end up multiplying what you have, your x to the r, so x to the negative 1, times the natural log of x. All right, if you want to write that a little differently, it's natural log of x over x. And then these are the two homogeneous solutions for this repeated root case for a Cauchy-Euler equation that is second order.